So here's an example of how we would use the first derivative test, and I'm going to use the same function that we used in an earlier problem because we've done a lot of the work already, so we can just use it to demonstrate a different point. So we have the function f of x equals x minus 1 over x squared plus 8, and the question is in the previous question about this function, the question was to ask where is the function increasing and where is it decreasing, which we use derivatives for. So now the question is going to be to identify the critical points of f and determine whether those points are local mins, local maxes, or neither. That's an x there, sorry. That is local maxes or neither. Okay, so recall that I put in some of the previous work that we can reuse just so I don't have to calculate it again. Recall that we had discovered that the derivative of f was this function. After we simplified it, it looked like this. You can go back to that video if you want to see the algebra there. And also, we had discovered that f prime was less than 0 on the two intervals negative infinity to negative 2 and 4 to positive infinity, and the derivative is positive on the interval negative 2 to 4. So what we want to do is first find the critical points. We'd sort of hinted at what they would be in the previous problem that we did. We're going to find the places where this function is 0. Note that there are no places where where the derivative is 0. Note that there aren't any places where the derivative is undefined because this denominator is always going to be a positive number. It can never be 0. So the numerator, however, we'll see that causes the derivative function to be 0 when x equals 4 or x equals negative 2. So the critical points are x equals 4 and x equals negative 2. So let's see what's going on at x equals 4 and x equals negative 2. I'll put in kind of a number line here, put in negative 2 and 4. So let's just see what's going on at negative 2. We can see that at negative 2, if we look at these intervals, for the interval from negative infinity up to 2, the derivative is less than 0. So what that means is that the function is kind of heading downward on this interval from negative infinity up to negative 2, and then once we get to the interval negative 2 to 4, the function is heading upwards. So what that means is that at the critical point negative 2, we see that the derivative changes from negative to positive, and that suggests to us that what we're seeing is a min, which we might draw in something like that. And then we examine what's going on at 4, and we'll see that we have a positive. Derivative, and then when we get to the interval from 4 to infinity, that's from 4 going all the way to the right, the derivative changes back to negative. So what that suggests is that up here we have a max. In other words, the function is heading upwards, it turns around and then starts heading downward. As we'll see a little bit later in the chapter, you can actually use clues like this to try to get like a very general idea of what the graph of a function looks like without plotting points. So it certainly seems like since these are the only critical points, which means these are the only mins and maxes, there's nothing in this interval that would look anything like one of these turns like this, because we know that we can only find mins and maxes at critical points. What that suggests is that this function might look something like this. So um, so anyway, we haven't really gotten to the point of being able to draw the graph, but hopefully I can at least make the case for you that that this test of just looking at the derivatives and what happens across a critical point should tell you whether that point is a min or a max.